And then when is it moving in the negative direction? Or when is the velocity negative?
Not including B, but like from after B to C,
To C?
to D, sorry,
D?
Yeah.
Am I including D?
yes.
And then over here, negative, negative, negative. I do want to point out something crucial here. If you're going from positive to negative or negative to positive, you have to pass through zero. You will not go from positive and then straight to negative unless there's a rip in the space-time continuum. And that is well outside the scope of, we'll just say reality as we know it. Definitely this course. Now, there has been one test where it did go from plus to minus, and because I messed up. And in that case, I allowed a couple different interpretations of it. But if it ever looks like it goes from plus to minus, or minus to plus without going through zero, either you've made a mistake or I made a mistake when I made the problem. All right, questions up to here? All right, acceleration is usually the tricky one. I want you to I'm going to give you a moment here to think about when is the acceleration positive, negative, or zero. Give you 30 seconds to come up with your own answer in your head.
The acceleration doesn't have a direction, right?
Oh, it's a vector. And yeah, I guess I should have taken the bigger clue there. But Elena mentioned it. I am talking about the vector acceleration here. All right.
Just a general question, the ball is always accelerating in this problem, right?
Is it?
Well, I wasn't asking about positive or negative direction, I'm just curious, is the ball always accelerating?
Is it ever zero?
I don't think so, because it's never like resting in the person's hand and it's not resting on the ground at any point in the problem.
So Caleb and Chikara, both of you seem to be shaking your head no or yes that acceleration is zero someplace.
B, right? Because then it's equal to.
All right, so we have a proposal that at B the acceleration is zero and a proposal that it is never zero. Time to place your votes.
I think it'd be at zero, I was just more like trying to ask a question about it, rather than like actually asserting my position.
Oh,
Yeah.
Okay, so you're backing off.
Yeah, well, I never backed on, but anyway.
Okay. So let's talk about that. This is the most common error I'm seeing when finding acceleration. At B, first off, what is acceleration? Think back
The
to
change in velocity over the change in time, right?
Yep. Acceleration, change in velocity over change in time. All right. So if acceleration is zero, what does that tell you about the change in velocity?
It's also zero?
Yeah. So if acceleration is zero, velocity doesn't change. At B, the velocity is zero. If that does not change, what would happen? What would the ball be doing? If the velocity is zero, it's up here, ball gets thrown up. At B, it stops for just a moment. If the velocity is zero and the velocity doesn't change, what would it do?
Just stay there.
Yes, it'd be a really cool effect if I could throw a ball up and it would just hover. But that also means that anytime you jumped up into the air, you would never come back down again. I think we as a species would be over if that were the case. Acceleration does not deal whether it's moving or not. It deals whether the movement changes or not.
Can you say that
And-
again?
Acceleration does not tell us whether an object is moving or not. It just tells us whether the velocity is changing or not. So at B, the velocity does change. It's going positive, it hits zero just for a brief moment, and then it becomes negative again. The velocity is changing the entire time. Grace?
So an acceleration of 0 wouldn't mean that it's not moving, it just means there's no change in that movement.
Acceleration of 0 means the velocity is not changing. That means you could be going at 50 miles per hour east, and that doesn't change.
Yeah,
Okay. I thought you said not moving.
well, like not changing, like
Yeah.
the movement's not changing.
Correct, the movement is not changing if acceleration is 0.
Okay. Wow.
What did you say the common mistake that you saw about acceleration was?
The common mistake is students assuming that not moving means acceleration is 0. And that not moving, if I just told you an object's not moving, I've told you nothing else about whether it's about to start to move or whether it's gonna stay not moving or whatever the situation might be. You cannot figure out the acceleration just from the idea that velocity is not changing. Sorry, from the idea that velocity is 0.
So don't assume that just because an object is moving, its acceleration is 0.
Yeah, you need more information. Knowing velocity or knowing acceleration does not tell you anything about the other one, just by itself. Object going 5 miles per hour, I don't know if it's accelerating or not. If it's going at a constant 5 miles per hour in the same direction, then I can make a conclusion. So, if at B it is not accelerating, sorry, wow. If at B it is accelerating, acceleration is not 0, that means what in terms of plus or minus? Think back over here. I said if you're going from plus to minus, it has to go through 0. If it's never 0,
So it would be all be positive then?
it's all positive or all negative. Now, in this particular case, which is it?
Positive.
Why? Is that just
Like
like,
we already established that there was, A was positive.
did we? When? I didn't think we had. If I said something to that effect, then I misspoke. All right, let's think about it this way. At A, it's moving up in the air, so let's give it a velocity. So if I had A, B, C, and D, I know the velocity is 0 here. At A, it's positive, so I'm just gonna say 10 meters per second. Just pick some positive number. It goes up, stops, comes back down. At C, it's negative 10 meters per second. And at D, we'll just say negative 20 meters per second. That's to indicate that it's moving upwards, that's why it's positive. It's 0, at this point it's heading down, the negative says it's moving down, and at D, it's going faster, downwards. I know that acceleration is the change in velocity over change in time. So if I go from 10 to 0, what is the change?
Minus 10.
Stephanie?
Minus 10.
If I go from 10 to negative 10, what is the change?
Is it negative 20?
Not negative, not from 0 to.
Oh, no, sorry, I was thinking about negative 10.
And if I go from negative 10 to negative 20, what is the change?
Negative 10.
If the change in velocity is negative the entire time, acceleration is negative. So it is negative the entire time. And then over here.
What would
Alright.
this problem look like if acceleration was positive the entire time? I
If
don't know.
acceleration was positive the entire time, that means I would have made down positive, and so All the
Oh,
positives become negative, the negatives become positive.
okay, okay.
What if we had started it like in the hand when the acceleration was at 0?
All right, that becomes a much trickier problem, but that would be sort of test level, so why don't we do that one next? We'll expand it. I want to make a couple comments about this, and then we'll do something like that. All right, now, if you are pushed, remember that the total force is in the same direction as acceleration. Chapter 4 concept, but sort of touched on it already. The total force is the same direction as acceleration. Which means if I am pushed in the direction I am moving, I will go faster. So if acceleration and velocity are the same sign, so in this region right here, acceleration and velocity are the same sign. It should be speeding up. Well, this is after the peak, so after the peak it does speed up the entire time. While it's moving up, the velocity and acceleration are opposite signs, which means it's going one direction but being forced the other direction, which means it slows down. And from A up till B, it is slowing down. So slowing down, speeding up. And that is not necessarily easy to see. So let's get away from that. Oops. Look at just right to get that 3D image. So another thing that one of those big mistakes that students have a hard time escaping is that we're talking vector acceleration. If vector acceleration is negative, that does not tell me whether something is speeding up or slowing down. I need to know the velocity in order to know if negative acceleration means speeding up or slowing down. Here it's speeding up, there it's slowing down. Let's look at this a different way. Same problem. Everybody loves a graph, I'm sure. Never verified that idea, but I just assume it's true. My position is 0 at the ground. So it starts off the ground, so my position starts here. It goes up, it peaks, and then it comes back down. So this is, if I did position versus time, that's sort of what the graph will look like. This is time A, time B, time C, and time D. And that's my time axis. My velocity graph I skipped displacement, we'll come back to that. Let's put the X there, X, repeated. My velocity starts positive. I know at B it's 0, so if I did B, C, and D, B at 0, it's negative after that. This actually, now the reason it is straight is because the acceleration is constant. In this case, that is something that you don't recognize yet, you will.
Can you explain that graph again? I was just kind of confused.
So velocity starts, I know the velocity is 0 at B.
Yeah.
The little or dot right there.
Mhm.
I know it starts out and then starts slowing down So as time increases, my velocity goes smaller. And then it goes in the negative direction, getting faster and faster and faster, in other words, more and more negative.
Okay. So the first graph is showing, what, is the first graph showing displacement,
Position,
position, and then this one is showing acceleration,
velocity,
velocity? Okay.
velocity, position.
Well, I guess I saw the time there too, and I was thinking, velocity over change in time equals acceleration, but anyway.
We'll connect that in just a second, actually. My acceleration and time graph. Acceleration is negative the entire time, and it is some constant. It's constantly negative. If I did a displacement first time graph, what would it look like?
Can you ask the question again?
If I did displacement first time, what would it look like?
Positive, just like straight.
It's, displacement's not positive all the time.
It goes to 0 at C, and then it continues down negative
All right, zero with,
at point C.
it's zero at point C, so if I had point C right here, it's zero. It's zero at A. What does it look like in between A and?
It's positive, so it would make like a little arc between A and C.
All right. The only difference between this graph and this graph is the starting point. So if I took this and shifted it up, I would get that, or if I took that and shifted it down so it started at 0, I would get this. So typically, like in the lab that you're gonna be doing today, I asked you to plot position, not displacement, because the only difference between the two graphs is basically the curve looks the same, it's just a matter of do I start it at the origin or start it at something else.
So for the graph we just did, where did we start it?
For the position graph,
Yeah, for the one that we just did. We're starting at which
without
point?
more information, it just starts at some positive number.
Okay.
Pointing out a couple other things, questions up to here?
How is the acceleration graph negative?
Well, we said it was negative the entire time.
Yeah, how is it like the straight line? Why does it go down?
All right, I think that segues into the next piece. And if we're done with the next piece and you're still unclear, we'll ask it again. All right, so we have this relationship right here. Acceleration is the change in velocity over change in time. Well, if I look at my velocity graph here, I take 2 points. Between those 2 points, I have some change in time here, I have some change in velocity here. I go from that point to that point, or go from here to here. If I did change in velocity over change in time, what's the math word for that?
Acceleration ratio?
Got it. Both valid, I was looking for more, I guess ratio is more math, but it's a magic word.
Slope?
This is a rise over the run. If it went up like that, perhaps it's easier to see the rise and run. If I take a straight line and I take 2 points on that line and I look at how far it goes up and how far it goes over and divide, rise divided by run, I get the slope. So, acceleration is the slope of the velocity versus time graph. I'm trying to give you multiple ways of looking at the exact same thing. If all of it clicks for you, excellent. If only part of it clicks for you, then you know where your strength is. You can either work on the other one or just try to look at everything in terms of the way that you look at it. So, acceleration is constantly negative here because this slope is constantly negative. Now, why is that slope constantly negative? Well, that will go back to this one. Because velocity is the change in position over the change in time. Well, that's just the slope of this. So velocity, slope of position reverse time. And since the only difference between displacement and position is where you start, it's also the slope of this. Or slope of position versus time. Now, what do you do for something like this? How do you figure out a slope for something that's curved? Assuming we're not using calculus. Well, if I want to figure out the slope at this point right here, what I do is I draw a tangent line. Draw a line that just basically touches at that single point, just sort of skirts at that point. And the slope at that point is the slope of that tangent line right there. Now, as far as we're concerned, the big thing we want is it a positive slope or negative slope? Is slope getting bigger, slope getting smaller? Well, this is a negative slope. Negative slopes go like that, positive slopes go like this. Zero slope goes like that. Positive, zero, negative. The slope is negative here. My velocity should be negative there. My slope gets more and more negative because it's getting steeper. My velocity becomes more and more negative. Here, my slope is positive. It becomes less positive, it's zero, then negative. So it becomes positive, becomes less positive, and then becomes negative. It all fits together, so if one part doesn't